Hey everyone, welcome to another Uiua programming video. Today we're looking at the first day of Advent of Code 2025. This one's pretty straightforward. We have a dial with the numbers 0 through 99 on it, and we have a set of rotations either to the left or to the right. And we need to do these rotations, and for part 1, count the number of times the dial is left pointing at 0 after any rotation, and importantly, the dial starts by pointing at 50. So let's get this into the Uiua pad and start with our parsing. So to start with, I'll do our usual PBBN idiom and put it into boxes for now. And let's think a bit about what we actually want to do besides just boxing it. And what would be nice is, of course, to turn these characters into actual integers. And for the left turns, we can store them as negative integers, and for the right turns, we can store them as positive. So let's unbox the first one here and just think about what processing we would want to do to this. So the first thing is we can use unjoin. This will split an array into its first row and the rest, which lets us operate now on the direction and the digits separately. And after that, we want to put an L on the stack, and now we want to check for equality between this first character and the L. And we also want to parse this third stack item. So for that, we have a dyadic modifier bracket, which lets us call two functions on two distinct sets of values. So in this case, the two functions are equals and parse. So this now gets us a 1, indicating that it is a left turn, and we have our integer. So we would like to run this now on all of our rows, or all of our lines of the input, rather than simply boxing. And now we have two vectors, one representing which are left turns, and the integers representing the actual rotation to be done. So the only thing missing now is that everywhere we have a 1, we would like to conditionally negate these integers. So you could reach for the switch modifier, but in this case, because we just want to either do something or not do something, we can just use repeat, and the function to repeat will be negate, and we'll either repeat it once or we will repeat it 0 times, and this will get us exactly what we're looking for. So now the question is, how do we actually step through this process of rotating the dial left or right and recording the state it's in, the dial number that it's pointing to, after each of these rotations? So in a more imperative language, this would be some kind of iteration for loop, and you'd have some kind of state variable where you'd be tracking and updating and recording whenever it landed at 0. But in a more declarative style, in an array language, we can turn towards the scan modifier. So this is a reduce but keep intermediate values. So basically, apply a function in between the rows of this vector, but keep the intermediate values. So what we want to do in this case is use the add function with our scan. And now if I keep the original one also below on the stack with the by modifier, we can see that we started at negative 68, we subtracted 30 to go to negative 98, we added 48 to go to negative 50, and so on. So this is exactly the operation that we want to do. We want to add each of these changes and keep track of where we end up. But there are two important things that we're not yet accounting for. The first one is that we need to start at 50, not at negative 68. So in Uiua, we can use a fill to provide an initial value for a scan. So that will take care of that. And the other thing is that the dial is from 0 to 99. So it's actually not possible to be at negative 68 or negative 18. So we need to use modulus to actually correct that. So we'll do modulo 100 here, and now this is giving us the wrapping behavior that we are looking for. And now we have all of the states that we end at, and we can simply count how many zeros there are. So we'll look for equality with 0, and we'll simply sum this vector using the reduce modifier, which we already a bit saw before, but rather than keeping the intermediate values like we did with scan, we just want to reduce this with addition, so summing it up, and that gets us our answer of 3. And I can get rid of this by modifier that was keeping the original vector. So this is our part 1 solution. And for part 2, we need to do the same thing. So we still want to, in the end, do rotations and count zeros, but now we need to count the number of times any click causes the dial to point at 0. And previously we were only looking if it's 0 at the end of a rotation, so now we need to look if it happens during a rotation. So how can we do that? Previously we were taking these full-size steps all at once, so we were moving left by 68 numbers or 30 numbers all in one step. But what we really need to do now is move left by one step 68 times, or move right by one step 48 times. So we'd like to have a vector that has -1 68 times, followed by -1 30 times, and so on. So how can we get that kind of vector from this input? The first thing that we could do is get the sign of the number. So this will tell us whether it's negative or positive, indicated by -1s and 1s. And this is already a good start. And then what we'd like to do is simply repeat this by 68 times, but not negative 68 times. So we can use a fork here, and we will also get the absolute value of the original vector. So now we have 68, -1, 30, -1, and so on. And this is exactly what we need to use the keep function, which will discard or copy some rows of an array. And in this case, we're telling it how many times to copy and which numbers to copy. So with this, we get exactly the vector that we're looking for. And then, as I said, the logic for turning and counting is actually the exact same. So we can simply call our P1 function, and now we get the answer of 6, which is exactly what we expected for part 2 for the example. So this is our part 2 solution. So we can call both these, put them here, and this is the whole solution. So there is one thing that we could look at here, which is how this is using a fork. It's actually fine, there's sort of no way to shorten this, but just because I think it's interesting, you can also use unmultiply, and this inverse is defined to give the absolute value and the sign. So this actually gives it in the opposite order of what we'd want, so we can use unback multiply, and then we can apply our keep. So it doesn't actually change the length or anything, but I think it's kind of cool to know about this additional functionality. So yeah, that's the first day. It's, I think, like I said, straightforward, but it's cool how we can take what in an imperative language would be this for loop where you're maintaining state throughout the whole thing, and use scan to take a more declarative approach where we just build up the whole vector at once, apply the modulo to the whole thing at once, and then do the summing and the checking of 0 and summing afterwards. So I think it's a nice one to show a bit of the power of declarative programming, and array programming. So, hope you found it interesting, and I'll see you in the next one. Thanks for watching.